Hey guys, this is Ankit and welcome to the Google Cloud Platform Task Series. We are doing a list of basic tasks to get ourselves familiar with Google Cloud Provider, that is GCP. We are following the DevOps Engineer and SRE learning path, also available at cloudskillsboost.google/paths. You can always get more details by going to the repository thecloudterminal01/learn-devops. For today's task, we have the following objectives. First one is enforcing strict mTLS mode across the service mesh. Then enforce strict mTLS mode on a single namespace. We will explore the security configurations in Anthos Service Mesh Dashboard. We will add authorization policies to enforce access based on a JSON Web Token, that is JWT. Finally, we will add authorization policies for HTTP traffic in Istio mesh. The total amount of time we will be spending will be around 21 to 24 minutes. So let's begin. First, let's confirm Anthos Service Mesh setup. We'll configure the cluster access for kubectl. Let's set up the environment variables for zone and cluster. Let's get the project ID and save it in gcloud project folder. Let's configure kubectl. Now let's check that our cluster is up and running. Let's ensure that the following Kubernetes Istio D services are deployed. So I'll check the services in Istio system. So we have them deployed. Let's check the corresponding Istio D pods are deployed and all the containers are up and running. So we have them up and running as well. Now let's deploy sleep and HTTP bin services. This will be our overall setup. We'll have 4 namespaces: legacy server, legacy client, mTLS server, and mTLS client. Sleep and HTTP bin services will be deployed among these corresponding namespaces. We have sleep and proxy in mTLS client. We have HTTP bin and proxy in mTLS server. Again, sleep is deployed in legacy client as well, and HTTP bin is deployed in legacy server as well. And then we'll try to do communications among these services over mTLS and plain text. So let's begin. First, we'll create the corresponding namespaces. All the namespaces are created, and this is the output. We created these namespaces just now. Now let's deploy our services in legacy client and legacy service namespaces. We are calling it legacy because these are not actually part of the mesh. So I will be running these commands. Now the sleep.yaml and http-bin.yaml are present in these URLs. You guys can go and check it out as well. Basically, the content of these YAMLs is as follows. We will be enabling auto injection of Istio sidecar proxy into the pods deployed in mTLS client and mTLS service namespaces. The Istio sidecar proxy is a container that runs alongside the application container in the same pod, and it intercepts all the inbound and outbound traffic to the pod. So as you can see in mTLS server, we have a pod running, and inside this pod we have HTTP bin and proxy containers. Similarly, in mTLS client namespace as well, we have one pod which contains the sleep container and the proxy container. Now it is responsible for implementing the mTLS encryption between services in the Istio service mesh and enforcing Istio policies such as traffic management, routing, and security. By auto injecting the sidecar proxy, we can ensure that all traffic between services in mTLS client and mTLS service namespace is automatically encrypted and secured by Istio. This eliminates the need to modify the application code or configuration and makes it easy to deploy and manage services in a secure and scalable manner. So let's go ahead and enable this. First, we'll get the revision label. Let's run the next command for version. Now let's label the namespace accordingly. We have labeled both mTLS client and mTLS service namespaces. We can actually go back and check whether the corresponding labels have been added or not. So in mTLS client, the label is already added. Similarly, in mTLS service, the label is also added. So now let's deploy the services in corresponding namespaces. I'll copy this and deploy them. Let's verify that the sleep service and HTTP bin service are each deployed in both mTLS service and legacy service namespaces. So I'll copy this and run the command over here. And we see that they are deployed. Again, let's verify that a sleep pod is running in mTLS client and legacy client namespaces, and an HTTP bin pod is running in mTLS service and legacy service namespaces. So I'll copy this and run this command, and we have the pods running. Now let's verify that the two sleep clients can communicate with the two HTTP bin services. So I'll copy this for loop and run the command over here. As expected, all the clients are able to communicate with one another. Now let's understand authentication and enable service to service authentication with mTLS. So I'm going to go back and check all products. Select Anthos and click over here. Go to Service Mesh. I'll go to this section and select mTLS service. Let me select HTTP bin and go to security. Over here, I'll notice that there are two services. The sleep service in mTLS client namespace is part of the mesh and has a sidecar proxy, and therefore we see the real name and communication goes over mTLS, which is the default behavior in Istio. The unknown service, which represents the sleep service in the legacy client, is not part of the mesh and has no sidecar proxy, and therefore we do not see the real name, and the communication goes over plain text. By default, Istio configures the destination workloads in permissive mode. When permissive mode is enabled, a service can accept both plain text and mTLS traffic. mTLS is used when the request contains the X forwarded client cert header. So let's go to Cloud Shell and send a request from sleep service in mTLS client namespace to HTTP bin service in mTLS service namespace. So I'll go back over here and run this command. And as expected, the request contained X forwarded client cert header. Now let's send a request from sleep service in mTLS client namespace to HTTP bin service in legacy service namespace, and this should not contain the header that we are looking for, and the communication should happen over plain text. So this did not contain the header. Again, let's go back, and finally we'll send a request from sleep service in legacy client namespace to HTTP bin service in mTLS service namespace. And over here as well, we should not see the header. And in this particular command, what we are doing is we are basically getting the pod name with this snippet. Once we get the pod name, we are running the command curl inside the container sleep, which is in this namespace legacy client, and whatever output we get from this curl command, we are grepping for x forwarded client side header. Now let's do one thing. Let's enforce strict mTLS mode across the service mesh. In strict mode, services injected with Istio sidecar proxy will not accept plain text traffic and will mutually authenticate with their clients. So in this mTLS server namespace, the HTTP bin service, which is injected with proxy container, will only accept the mTLS traffic. It will not accept if any service tries to send traffic over plain text. For that, we are going to create a peer authentication resource for the entire service mesh. So I'm going to go ahead over here and run this command. Now let's again run this nested command loop and see our setup. As expected, the traffic from sleep service in legacy client namespace to HTTP bin service in mTLS server namespace is rejected. Now let's remove the mesh-wide mTLS peer authentication resource by running the following command. So I'll go back over here and run this command. And now we are again back to from where we started. All the traffic is now again allowed. Now we are going to enforce strict mTLS mode on a single namespace. In the Cloud Shell, I'm going to create strict mTLS service namespace. The namespace is created. Let's enable auto injection of Istio sidecar proxy on the new namespace. Let me copy this command as well. And now let me enable auto injection on the namespace. Now I'm going to use Cloud Shell to deploy another instance of HTTP bin service in strict mTLS service namespace. So I'll copy this and run the command over here. Now I'm going to create a peer authentication resource, but this resource will only be available in strict mTLS service namespace. So let me create this. The resource is created. Let me try to send traffic and verify that the HTTP bin service in mTLS service namespace still accepts the plain text traffic. So I'm going to go over here and run this command. And as expected, we get a 200 OK. We get a 200 OK because this peer authentication resource is created in strict mTLS service, and therefore it only affects the services within this namespace. Any service outside this namespace is not affected. Therefore, if we run this command for a HTTP bin service, which is inside strict mTLS service namespace, the plain text traffic should be rejected. So I'll go back over here and run this command. And as expected, the plain text traffic is rejected. The same service, that is HTTP bin service in strict mTLS service namespace, will accept mTLS traffic. So I'm going to copy this command and run it over here, and we should get a 200 OK response. Now let's clean up our resources. So I'll go back over here and run this command. In our next step, we will leverage request authentication and authorization policy resources. So we're going to create this kind resource authentication type of resource. So let's go ahead over here and understand a little bit about this resource type. Now this is a Kubernetes YAML configuration for an issue request authentication resource, which specifies how to authenticate incoming requests based on their JWT tokens. The name of this resource is JWT example. It is present in mTLS service namespace. This particular section defines the target workload to which the policy applies. In this case, any workload with the label app HTTP bin, it will be applied to that workload. Now this particular section specifies the rules for authenticating incoming requests based on their JWT tokens. This specifies the issuer that the JWT token must come from in order to be considered valid. In this case, the issuer is from testing@secure.istio.io. Together, this request authentication resource specifies that the request to the HTTP bin application must include a valid JWT token with an issuer of testing@secure.istio.io, and that the signature on the token must be verifiable using one of the public keys specified at this given URL. So let's go back over here, copy this command and apply. So now let's send a request with an invalid token and see whether it's denied or not. Again, in this command, we are getting the name of the pod using this snippet. Then inside the sleep container in the pod, we are running a command. The command is this. We are running curl in silent mode. The output goes to dev null. The header for this request is this. We are sending basically an invalid HTTP token, and we just want to see the HTTP response code. So I'm going to copy this command and run it over here, and we get unauthorized. Now let's verify that a request without a JWT token is allowed. So I'll go back over here and run this command, and we should get a 200 OK. Now let's create an authorization policy resource for HTTP bin workload in mTLS service namespace. We will copy this and run the command over here. Now let's also have a look at this authorization policy resource type. This is basically a Kubernetes YAML configuration for an issue authorization policy, which defines access control rules for traffic flowing through the issue service mesh. This defines the target workload to which the policy will apply to. In this case, it will apply to any workload with the label of app HTTP bin. This sets the default action for the policy to allow traffic. This specifies list of rules for controlling access to the workloads. Now, this specifies the request principal that must be present in order to allow traffic. In this case, the rule allows traffic from a source whose request principal matches the given string. Now the policy requires all requests to the HTTP bin workload to have a valid JWT with request principal set to this string. So let's download a legitimate JWT that can be used to send accepted requests. So I'm going to copy this URL, and let me go back over here and run the command. Now let's verify that a request with a valid JWT token is allowed and a request without a valid JWT token is denied. So first we'll run this command, and the expected output is 200 OK. This time we sent a valid JWT token. Now let's run a command without a valid JWT token, and as expected it is denied. Now we'll start authorizing requests based on method and paths. For that, we are going to go ahead and copy this authorization policy and apply it over here. Let's also try to understand this authorization policy. So over here, the default action for the policy is to allow the traffic. This is the request principal. This specifies the operation that this rule applies to. Over here it is being applied to HTTP GET method. Together, this authorization policy specifies that the request from a source whose request principal matches this given string are allowed to access the HTTP bin application, but only for the HTTP GET method, and the path is /IP. So now let me send this request to a valid endpoint with a valid token. So I will copy this command and run it over here. As expected, I get 200 OK response. Now, if I send the request to a invalid endpoint with a valid token, I should get 403, that is forbidden. As expected, we get a 403 response code. Let's delete our authorization policy. So I'll go back over here and run this command. So this completes all of our subtasks. That's all for today. See you in the next video.